Welcome to our competency-based question series designed chapter-wise to enhance your conceptual learning and understanding. Question 9. Coil 1 has self-inductance L1, which is 3 times the self-inductance L2 of coil 2. If during a certain instant, the rate of increase in current and the power dissipated in these two coils is the same, then we need to determine the ratio of the induced voltages in the two coils, the currents flowing in the two coils, and the energy stored in the two coils. So this is coil 1, and let us assume that I1 is the current that is being induced here, and E1 is the voltage induced in this coil due to the rate of change of current I1. And for coil 2, I2 is the current induced and E2 is the EMF induced due to rate of change of current, and it is given that P1 is equal to P2, that is the power dissipated in coil 1, it is equal to power dissipated in coil 2, and also dI1 upon dt is equal to dI2 upon dt. So these are the two things that are given to us. We know the EMF induced in a coil is self-inductance times the rate of change of current in the coil. So E1 is the EMF induced in coil 1, EMF induced in coil 1, and it is equal to the self-inductance times L1 times the rate of change of current in the coil, di1 by dt. Similarly, E2, the EMF induced in coil 2, it will be L2 times di2 by dt, the rate of change of current in coil 2. So this is my equation 1 and this is equation 2. Let's divide these two equations. So dividing equation 1 by equation 2. So we have E1 upon E2 is equal to L1 times di1 by dt divided by L2 times di2 by dt. And it is given to us that the rate of change of current in coil 1 at an instant t, it is equal to rate of change of current in coil 2. So we can cancel these two out and we are left with E1 upon E2 is equal to L1 upon L2. And it is given in the question that L1 is 3 times the self-inductance L2. So it is given that L1 is equal to 3 times L2. So in place of L1, I can write 3 times L2. So E1 upon E2 will be equal to 3 times L2 divided by L2. L2 gets cancelled out with this L2. And we are left with the ratio of the induced voltages is 3:1. So this is the induced voltages. Now we need to find the ratio of the induced current as well. For that, we will be using the second information given to us, that is the power dissipated in the coil is same. So let's take part B. So power dissipated in coil 1. So P, it is equal to VI. And in place of V, I can write E1, I1 for coil 1, and that is P1 for coil 1. Similarly, for coil 2, P2, it will be E2, I2. And we know this thing, it is given in the question that P1 is equal to P2. So we can write E1 upon E1, I1 upon E2, I2, it is equal to 1 because P1 it is equal to P2. So both will be cancelled out and we are left with 1. So we are left with E1 I1 is equal to E2 I2. And from here we can find out I1 upon I2 is equal to E2 upon E1. And this ratio we have already calculated, E1 1 divided by E2, it was 3. So E2 upon E1 will be 1 by 3. So the ratio of current will be 1 by 3. And let's take part C as well. In part C, It says we need to find the ratio of energy stored in the two coils. So energy in an inductor coil is given as U is equal to half L I square. So for coil 1, U1 will be equal to half L1 I1 square, and U2 will be equal to half L2 I2 square. This is energy for coil 2. And let's divide these two because we need to find the ratio of energy in coil 1 to energy in coil. So U1 upon U2 will be equal to, half gets cancelled out with this half. It will be L1 I1 square divided by L2 I2 square. And I1 upon I2 we know it is 1 by 3. So squaring both will be getting 1 by 9. So it will be equal to L1 upon L2 multiplied by 1 by 9. And we know this thing that this L1, it was given to us as L1, it was equal to 3 times L2. It is given in the question. So we can put in place of L1 3 thrice of L2. So that will be 3 times L2 divided by L2 multiplied by 1 by 9. L2 gets cancelled out with this L2. 3 and 9, we can cancel it. And the ratio of energy stored in the two coils has come out to be 1 by 3. So the ratio of current is 1 by 3. The ratio of energy is 1 by 3. But the ratio of induced EMF is 3. And that's the answer for this question. Thank you. Keep learning, keep practicing, keep excelling.